Let's consider the word mathematics. How many letters are there with mathematics? That's where we start. How many letters are there with mathematics? All in all?
11.
We have 11. So I'm going to say that A, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't care whether they are identical letters or they are not identical letters. I just say there are 11 letters that I need to arrange.
Yes.
Now, how many ways can I arrange these letters? I can arrange them in 11 factorial ways.
Yes.
So I'm going to tell them with these letters can be arranged 11 factorial ways. Now, this is how I'll do a question whether they're identical letters or they are not identical letters.
Yes.
The next thing that I'm going to do then, I'm going to go and say, but M, is M identical with any other M? Is there any other M except this one here?
Yes.
There is an M. Yes. How many letters do you have? If they're 11, I'm not sure, I didn't check the number. It's 11. Okay. So we have 11 letters that we can arrange. We have 11 spaces.
Yes.
So we're going to put 11 factorial. Okay, it's fine. Then from there onwards, we ask the following question. How many letters are identical? We have M. M is repeating itself 2 times. So there's M and then there's also M. So what are we going to do with this M? We're going to say M. Because there are 2 M's, we're going to say it's 2 factorial. So we're going to take them out.
Yes.
This is M. Yes. We are done with M. Next, do we have any other letter which is repeating itself, which is identical with another one?
Yes.
We do have. Who's that? We say A. How many A's do you have? 1, 2. So for A now, I'm also going to say multiply by 2 factorial. This is for A. English. The blue one was for what? For M. Do you still have other letters which are identical?
Yes.
What are those letters that are identical? T. T. How many times is T repeating itself? So let's say T was repeating itself 3 times. I was going to say divided by 3 factorial. So in this case, because it's 2, I am going to say that multiply by what? By 2. Then I'm going to look for the answer of this thing then. Hotter, don't sleep. How? All right. What is the answer that we get? Huh? 8. 8. I like you can't do it. Huh? And how did you do it? I'm sure you need to go there and say 11.
Yes,
It's 11 factorial. All over. Ne? 2 factorial multiplied by 2 factorial multiplied by 2 factorial. And this is not probability. This is the number of word arrangements that we can have when we're using the word mathematics. Ne?
We divide by the number of letters that are repeating themselves.
Yes, that are identical. Yes. It's, this is A, this one. How many word arrangements can be made? It's 4, 9, 8, 9, 6, 0, 0. That's all. Okay, sharp. And then here we have, that one we're done. Start and tested. Why did we divide, guys? We didn't divide because it's probability. No, we divided because we are trying to remove the repetition. Because M is repeating, it's going to be, like, how would you tell a word that is starting with this M and then ending with that other M? We have no idea. So it's starting with an M and then it's ending with the M. It doesn't matter. They are going to be exactly identical. So I'm going to try to remove those letters, those words that are going to be giving us exactly the same thing. Let's go to number B. On number B, they say, how many word arrangements can be made with this word if word has to start with an S? So we're starting with an S. No?
Yes.
So number B. On number B, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No? Yeah, I wanted to see if you're awake. So we start with an S. How many S do you have? You come and put the 1 S that you have there. No? As soon as you have put the S, then you can say, how many things do you still have to arrange from there? 1, 2, 3, 4, 5, then it's 10 factorial. But out of the 10 factorial things that you have to arrange, but There are things which are identical. Who are those people who are identical? Let's go and talk to them. Let's talk to them. Who are those people who are identical? It's 2 factorial, which is m,
Yes.
multiplied by 2 factorial, which is a, multiplied by 2 factorial, which is what? Which is t. And then all in all, we are going to remain with what?
4, 5, 6.
It's 4, 5, 6,
6, 0.
6, 0, 0. Like this. Okay. What is the probability that the word will start with an S? Yes, I has probability. What is the probability that the word will start with an S? Number C. We are going to say to them, okay, it's simple. Is your hand up, Pastor? Yes. Huh? Huh? Oh, the probability, huh? 4, 5, 3. 600. Okay. What is the probability that we start with an S? So we're going to have 4, 5, 3, 600 all over. It was 4. What was this? What did I write here? I wrote this.
4, 4, 9,
It's 4,
9, 8, 9,
9,
8, 9,
8, 9,
6, 0.
6, 0, 0. I wrote this.
Yeah.
Okay, what do you get as your final answer?
1 over 88.
1 all over 88. So there's 1 of 88 chances that you will create a letter with a word which starts with the letter S. Now, this one is the one that I wanted us to talk about. Let's look at this one before we shift here. What happens if they say the word starts and ends? A word can start and a word can end. Here's what I want us to try. I want us to try starting with an M first. I want us to start with an M. And then since we're starting with an M, how are we going to do this one? Let's say which Bonade just said starting with an M. What is the problem with M? M is repeating. Unlike this one S was not repeating itself. It was not identical with anyone. So we right here it was 1 over 88. But 188. Okay, we move on. So what happens if we talk about mathematics, but we wanted to start with an M first. Let's start by doing something like that. Start with an M. How would we do that one? How? That's the question.